We use it every single day, all around us, an invisible network that's silently standing guard, protecting us from one of the most powerful forces we've ever harnessed, electricity. We flip a switch, we plug in our phones, and we just expect it to be safe. But you know what? That safety is no accident. It's all by design. So today, we're going to pull back the curtain and make that invisible network visible. Let's dive into the world of electrical earthing.
So let me ask you this. What's the most important wire you can't see? Hint, it's not the one that's actually powering your device. It's the one that's just sitting there, waiting to save your life if something goes horribly wrong.
Think about it. In every single building, from these enormous construction sites to the very walls of your own home, there's a hidden safety system at work that hopefully you will never, ever need. Because the same electricity that powers our world can be incredibly dangerous if it doesn't stay exactly where it's supposed to. And that gets us to the heart of the problem, something called an earth fault. I want you to picture this. Inside your washing machine or maybe your toaster, a live wire has jiggled loose and it touches the metal case on the outside. Instantly, that entire metal surface becomes live, humming with a potentially lethal voltage, just waiting for a hand to touch it. That is an earth fault.
So, how in the world do we protect ourselves from that? Well, the solution is actually kind of brilliant in its simplicity. Earthing is basically electricity's fire escape. It's a dedicated, super safe path for that dangerous fault current to get the heck away from the appliance and flow harmlessly into the ground. Or, you guessed it, the earth.
But here's the thing. Just like with fire escapes, there isn't just one single design. And to get a handle on the different types, we first have to learn the language. Now, it might look like a jumble of letters, a bit of alphabet soup, but trust me, it's actually a pretty simple code once you crack it.
And you know what? This alphabet soup is way easier than it looks. T comes from the French word terre, which just means earth. N stands for neutral. S is for separate, and C is for combined. That's it. Just remember those 4 letters because they are the building blocks for understanding pretty much every system out there.
Okay, so now that you're armed with that secret code, we can start to look at the 3 main blueprints for electrical safety that you'll find almost everywhere, from public buildings to residential neighborhoods.
First up is the TNS system, and that S is your big clue. It stands for separate. In this setup, the protective earth wire and the neutral wire are kept completely separate, all the way from the power station to your house. It's considered really, really safe, but it has one major weakness. If that protective earth wire breaks somewhere along the line, the system has no way of knowing. Your safety net could just disappear without any warning at all.
Next, we have the TNCS system, which you'll notice uses both C for combined and S for separate. What's going on here? Well, from the power supply, the earth and neutral are combined into a single wire. Then, right when it gets to your property, it separates out into 2 different connections. This hybrid approach is super common, and you'll often hear it called protective multiple earthing or just PME.
And finally, there's the TT system. The 2 T's tell you everything you need to know. The power supplier has its own connection to earth, and you, the consumer, have your own completely independent connection to earth. This is usually done with a metal rod or plate that's literally buried in your garden. With this system, you are using Mother Earth herself as the return path for any dangerous fault current. Pretty cool, right? So which one is the best? Well, this is where it gets really interesting, because there is no single right answer. It's all about trade-offs. The TNS system is often seen as the safest, but it's also the most expensive because of that extra separate wire. The TNCS, or PME, is a good middle ground on cost, but it comes with the highest risk if that combined supply wire breaks. And the TT system? It's cheap on wire cost, but it has a high earth fault loop impedance, which is just a fancy way of saying the ground puts up a lot of resistance to electricity. So it absolutely must have a super fast safety switch, called an RCD, to work properly.
So, if we've got all these different trade-offs, how on earth do you choose? Well, the answer is that it all depends on the context. You absolutely cannot just pick one system and use it for every situation, because in certain locations, the risks change dramatically.
And that brings up a really key question. If that PME system is so popular and so common, why is it actually forbidden in some places?
A caravan park is the perfect example. Remember that big, scary risk we talked about with PME systems, the broken supply neutral? Well, imagine if that happened in a caravan park. The shared earth connection could make the metal body of every single caravan on the site dangerously live, all at once. Because that risk is so catastrophic, the regulations just say no way. Each caravan pitch has to have its own separate earth connection.
You see a very similar story with a lot of rural properties, especially those that get their power from overhead lines.
The power company often just can't guarantee the safety of that long, exposed earth wire. I mean, it could get damaged by falling trees or even stolen for its copper. So they often won't even provide an earth connection, which means the property has to install its own TT system.
And that same principle applies to all sorts of other high-risk places: petrol stations, construction sites, boat moorings, you name it. Any location where the risk of a broken wire or a stray electrical current is higher requires a completely different safety calculation. It all comes down to a really careful assessment of what could possibly go wrong.
So after all these acronyms and diagrams, the TNS, the PME, the TT, what's the big takeaway here? It's that all this complexity, all these different designs, and all these rules are all engineered for one beautifully simple goal: to provide a reliable, life-saving connection to the Earth.
And this brings it all home. You've probably seen a label just like this one near your fuse box or electrical panel. It is not just a polite suggestion. It's warning you about a critical link in this entire engineered safety system. That simple, physical connection is the final, crucial piece of the invisible network we've been talking about. All right, so let's boil this all down. What are the key takeaways? First, and most importantly, earthing isn't optional. It's your fundamental protection against electric shock. Second, there's no single best system. It's always a calculated trade-off between safety, cost, and risk. And finally, context is everything. The right choice for a house in the city is the totally wrong choice for a caravan park. It's a silent, invisible network, and it is always on guard for you.
It really makes you think, doesn't it? We are completely surrounded by this complex, life-saving network, and most of us never give it a second thought. Which leads me to a final question for you. What other critical, invisible systems are out there protecting us every single day that we totally take for granted?